Hi, I am Tapan Chakraborty. Welcome to my channel Fly with Tapan. Here I discuss aviation and space related topics. If you are interested to know about this world, then please subscribe now and hit the bell icon. Every Tuesday I upload an interesting video.
How nicely and smoothly the aircraft is doing aerobatics. This is the combined result of man and machine. But do you know what are the different control surfaces that produce this movement during aerobatics or during normal flying? Control surfaces are the panel which, when operated by pilot, comes out from the wings or fuselage or change its angle with airflow and creates aerodynamic force. This force causes to move the aircraft about different axes. There are different control surfaces on the aircraft to perform all these movements. These control surfaces move with hydraulic pressure. The pilot only has to give input with gentle push on control stick, rudder pedal, or some other input device in the cockpit. We will see one by one the function of all these control surfaces. The yaw moment. This is to move the aircraft about its vertical axis. This is the fixed vertical fin of aircraft. At the rear end of it, movable control surface is fitted known as rudder. Let's see from the top of the aircraft. When rudder turns towards left, the high airstream coming on the rudder will be deflected this way. As per Newton's third law of motion, that is, every action has an equal and opposite reaction. As the rudder pedal pushes the air towards left, the air will push the tail of the aircraft towards right. As a result, the whole aircraft will rotate about its vertical axis in this manner, and aircraft will take a left turn. The same way, for the right turn, the rudder pedal will be deflected towards right and the aircraft will take a right turn. Next come the bank or roll movement. To perform this movement, there are two control surfaces known as aileron. They are situated at the trailing edge of the wing and towards the wing tip. These two ailerons move together but in opposite direction to each other. So the airstream will push one wing tip upward and the other wing tip downward, and they will turn the aircraft along with its longitudinal axis. During turning of aircraft with the help of rudder, the aircraft will has to bend at the same time. Then the nose-up movement of the aircraft or the pitch. It is to move the aircraft around its horizontal axis. To do this, here is the elevator. When the elevator moves this way, then the airstream will be diverted up and the airstream will push the aircraft's rear fuselage downward, and it will make the aircraft to move about its horizontal axis. And to make the nose down movement, the elevator has to move in the opposite direction. The elevator, the rudder, the aileron, these all are called primary control surfaces. Let it be any type of aircraft, these three control surfaces will be there. Now we will see some additional control surfaces which are called secondary control surfaces. This is to enhance the performance of the aircraft. Though not all, but most of the aircraft is having these control surfaces too. These are flap, air brake, spoiler, etc. This is flap, situated at the trailing edge of the wing, in the inner side. Both the flaps operate together in the same direction. It can produce lift as well as drag, depending upon at what angle it is set. At the time of takeoff, it comes down at an angle between 15 to 25 degrees. Its deflection angle varies from aircraft to aircraft. When flap comes down during takeoff, it increases the surface area and also change the shape of the wing, helping to produce more lift. So with the lesser speed, aircraft can take off and also require a lesser runway. But during landing, it comes down more, around 60 degrees. Now it produces comparatively less lift and more drag or air resistance or brake for the aircraft. When aircraft fly at their assigned speed, that time flap is totally withdrawn. Now we will talk about spoiler, the control surfaces which comes out from the top of the wing in a very steep angle, and it produces drag and decrease the speed of the aircraft after landing. See the military transport aircraft. It is in the landing approach. The flap has come down in a very steep angle to produce drag or the air resistance. Watch its landing. After landing, the spoiler from the top of the wing comes up. It causes the air resistance to reduce the speed of the aircraft and also applies the downward force on aircraft, thereby more load on tire and create effective braking. At the last, the air brakes. It generally comes out from the fuselage of military aircraft, operated by pilot at the time of landing or just after touchdown. The purpose of it is to create air resistance, thereby reducing the speed of the aircraft and help to stop the aircraft in a shorter runway. If you feel the information I shared with you is valuable and interesting, then please consider subscribing to my channel.